Oh yeah! In this video, we are going to learn how to solve quadratic equations with the method of factoring. We need to use this whenever we have a situation where we have all of a sudden a b term, meaning in a previous video I showed you how to solve when we just have something squared. So if we just have x squared, c squared, but no 3c, then you can isolate the squared term. Here though, we can't do that. Right? And I'm going to show you what happens when we do that. So let's just say that we wanted to get c squared alone. So you add 18 to both sides. I'm going to show you what not to do. We get c squared plus 3c equals 18, and then we'll subtract 3c. So now that leaves me with c squared equals negative 3c plus 18. Ooh, so then I take a square root of both sides, right? Remember, plus or minus the square root. Uh-oh. The problem is, within that square root, I have my c value. So I wanted to get c alone, but I didn't. So solving for c squared by isolating it does not work when you have another power of c. Only when you have just c squared alone. So that's not the way to go. So then what do we do here? Well, we erase that work and we factor if we can. So the question is, if we can factor, do it. Maybe that's not the question, that's the action. So why would I want to factor this? Well, if you go back to a previous video, I showed you that a times b equals 0, so then either a or b equals 0. So watch what happens when we factor this thing. It's beautiful. So going back to factoring, and if you're having trouble still with factoring, watch my previous videos on how to factor trinomials. We have just a 1 out front, so we're saying what numbers multiply to negative 18 that add to 3? That would be 6 and 3. So we'd have c and c. So that would be a positive 6 and a negative 3, right? Negative 3 times 6 is negative 18. Add them together and you get positive 3. Ah, look what we have. We have a setup where now I can set each piece equal to 0 as I showed you in a previous video. And if you haven't watched that video, dudes, watch it. So either this is 0, c minus 3 is 0, or c minus 6 is 0. Nice! So all we do is solve these. I add 3 to both sides. That would be c equals 3. If I add 6 to both sides, I'd get c equals 6. And those are my two solutions. Now here's the key. This is just the same thing as that. So if I found the solutions to this equation, I have found the solutions to that one. Let's still check our answer though, and we'll check it in the original equation just in case we factored wrong, but solve this correctly. Then we wouldn't have the correct answers to this. So let's check our answers, and we'll just check them on this one. So I take 3 and I plug it into this. I get 3 squared, c squared, plus 3 times 3, minus 18. And the question is, does it equal 0? Well, 3 squared is 9, and 3 times 3 is 9. And 9 plus 9 minus 18, well, 9 and 9 is 18, minus 18 is 0. We would do the same thing with negative 6. Ooh, I made an error here. I just realized that, and that's why we check our work. This was c plus 6. I copied it wrong. So we would subtract 6 from both sides and get negative 6. And that's why we check our work, peeps. All right, so negative 6 I'll plug in here. So we're going to square negative 6 plus 3 times negative 6 minus 18. Question is, does it equal 0? Well, negative 6 squared is 36. 3 times negative 6 is negative 18. Minus 18 is 0. 36 minus 18 is 18, minus 18 is 0. So it checks out. All right, I just wanted to show you the full gamut of what we could do, but the number one idea here, before we forget it, is factor when you can. And once you do, it's setting each individual factor equal to 0. The why behind that? Check that out in my earlier video on the zero product property. All right, let's do one more for practice. Here you have 3x squared minus 2x equals 21. We need to get the 21 over to the left-hand side and set it equal to 0. The reason being is we're not isolating x squared here because we have this term. We're going to try to factor this. And if it does factor, we need to get both factors equal to 0 because it's the zero product property. It's not the 21 product property. All right? So I'm going to subtract 21 from both sides. That's huge. Get everything equal to 0 when you're factoring. And I'll talk more about that at the end of the video too. The 21 does not combine with any of the terms, so here we have it. So now we're going to factor this. Again, if you need help factoring it, please look back on the previous videos of how to factor. I'm not going over that. I'm just going to assume you know that because it's been taught in previous videos, so check out the videos in chapter 9 on factoring if you need to, and that's totally cool if you do. So now, let's see, we got to plug in numbers, and it's a bit of guess and check here. So I know the factors of 21, just kind of putting them up here, would be 1 and 21, 3 and 7. So I'm going to start with 3 and 7, and I'm going to put the 3 here because 7 times 3 would be really big. So 3 and 7. And 3 times 3 is 9. 7 times 1 is 7. 9 and 7, well, I need it to be a negative 9 and a plus 7. And that would work out. So there are my factors. Here's the important part. Again, had you left it equal to 21, two numbers multiplied to 21, there's two options right off the bat, but you could use fractions, or you could have 21 over 2 times 2 gives you 21. So my point is, there's only one logical way to say two things multiply to 0. That's if one or both equal 0. And so that's why we got to set everything equal to 0. Okay, so now I take each individual part of the factor, I set each equal to 0. 3x plus 7 is 0, or x minus 3 is 0, and I solve. So I subtract 7, so it's going to be 3x equals negative 7. Divide by 3, x equals negative 7 thirds. Beautiful. Or, we got one other value, x minus 3 equals 0. So I'm going to undo minus 3 by adding 3 to both sides. X equals 3. Again, we could check our answers by plugging in both into the original equation. If I plug 3 into here, I do end up getting 21. And as nasty as that is, if I plug negative 7 thirds in for x, I get 21. All right, peeps. In the next video, I'm going to lace through a whole bunch of practice problems just to make sure, if you need that extra practice, that you've got it and that you're exposed to a few different kinds of setups. Can't wait to see you there.